Hamming. These are all big names. So now the Hamming says that if you take any two strings, the errors basically are the exclusive OR. So basically, if you take this bit and you sent this and you got that, you do the exclusive OR and you count the number of ones, that is the distance between them. That is the Hamming distance. Okay? You can easily measure the Hamming distance. So now, the error correction. So basically, what we can do is, and I'm going through lots of wireless physical layer, communication theory quickly. So jumping from one topic to the next. Thing is, suppose you want to send 0, 0, and we can decide that whenever you want to send 0, 0, I will send 5 zeros. When I want to send 0, 1, I will send 0, 0, 1, 1, 1, 1. When I want to say 1, 0, I will send 1, 1, 0, 0, 1, and 1, 1, and so on and so forth. So, this advantage of this coding, error correction coding, this is actually error detection, error correction coding, is that if I received this 0, 0, 1, 0, 0, this is not one of the 4 codes that we agreed, right? But what we received here has a distance from each of these 4 codes. These 4 codes can be put on a 5-dimensional space, and this one we will find that it has a distance of 1 from 0, 0, 0, 0, all zeros. It has a distance of 2 from 0, 0, 1, 1, 1. Can you see that? Right? And distance of 4 and 3. So the most likely, these things would not have happened. This was the thing that you sent, 0, 0, 0, 0. Most likely. Right? And therefore, you really sent a 0, 0. So this is a 0, 0. Yeah, so that's the whole theory. Coding theory is a subject that will take several semesters. I will not go into that one. And I mean, actually, we do it all the time. I learned it myself. But that's a field. And so coding theory will not go. But let's say we somehow, some expert coding theory person sat down and said, this is the right code to use. Then basically we can do the error detection and correction, because when we receive this, we know that there is an error. Nobody will send that one. And then we can even correct it, because we can say it is 0, 0. So instead of 0, 1, 1, 0, 0, it is 5 zeros. Similarly, if you receive that, then you can figure out. In some cases, it is distance 2 from everything. So now you are not really sure. So it is same distance from 2 places. So it is equally distance from this and that. Now you cannot be sure which one it is. Right? So it can be detected but not corrected. So now we know that there is an error, but we cannot correct it. If it is close to something, we can say, okay, all right, most likely this is it. But if it is equally close from 2 different ones, then we have to say that this is detected but not corrected. And if there are 3-bit errors, they will not be detected. So you send that and you receive this, bad luck. It will just go through. And you will have to find some other method of detecting and correcting them, which we will talk about. But at this level, where people are sending bits, and these are the physical layer people, they have designed these mechanisms for their use, so that for every little bit that they receive, they can figure out that there is an error that can be corrected, and so on and so forth. So this is error correcting code, ECC. So we'll continue. Okay, so the optimal is your personal definition. The question is, there an optimal length? So if you want to send 2 bits, if you code it into 3 bits, you get some performance and there is some cost. If you send it as 4 bits, there is better performance and more cost. If you send 5 bits, so it continuously goes like that, right? Now the question is, where is the optimal? How much money you have? And so basically that's what it is that at some point you say, I don't think I want to pay $100 for this little device, And so that is what it is. It basically, the more bits you send, the more performance. We will see. Basically there are some formulas which tell you how much you get by increasing. So at some point you will say it's not worth the cost. The question is, The error more than the maximum Hamming distance will not be detected. No, hold on. If the Hamming distance in this particular coding, there is no such thing as maximum Hamming distance. In this coding, the maximum Hamming distance is 1. I mean, basically, 1 will be detected and corrected, 2 will be detected, 3 will not be detected. So what is the maximum Hamming distance? Maximum Hamming distance could be 5. There are 5 bits. Huh? Right. So what she is saying is, among these 4 words, they have been located in this 5-dimensional space such that between any 2 words, there is a minimum Hamming distance of 3, not maximum. Minimum Hamming distance of 3. So 0 and 0, 1, they are different by 3. These 2 are different by 3 and different by 3 and so on and so forth. So minimum Hamming distance is 3, and that actually is the important thing. Because if you know that the minimum Hamming distance is 3, you are in trouble. Right? You can't detect, you cannot correct. More than 3, you are in bigger trouble. You might be doing much more harm. Less than 3. Now you have to worry about 1 and 2. So 1, obviously, we always correct. We somehow believe that 1 is, quite possible, and we just correct it. And 2, basically, then you have to see if the word that you received is distance 2 from 1 and everybody else it is 3. Then, you might say, okay, all right, I will correct it. But if it is 2 from 2 different points, which is possible, in which case you won't be able to correct it. So what you do is, you measure the Hamming distance of the received from the code. Right? We call it code book. So you measure the Hamming distance of the received word from the code book, and then you say, well, whichever looks like closest to it, and if there is nothing such thing as 1 closest to it, then we say, okay, we detect, but I can't be sure which one it is. Right? And if you go more than the minimum Hamming distance or equal to the Hamming distance, then you won't even know. Yeah, of course. So thing is, if probability of 1 bit error is p, 2 bit error is p square, and so on and so forth, you multiply that. And the p, by the way, is 10 raised to minus 9. Okay? So if it is 10 raised to minus 9, 1 bit error. Okay, so what is the probability of 2 bit errors? It's very low. So and you say, okay, I will take that probability.